So last time we looked at like the graphical type analysis for VT graphs and getting out acceleration quantities. So now let's look at more of a traditional type of setup and just start nice and simple. Okay, so here we can just take something like this. We've got some road here. We've got, let's just have somebody, something like this. Going to make a little bike. Okay, let's get a bike. Bike frame. All right, some pedals. Kind of a weird looking bike. All right, so let's put somebody on here. Okay, there we go. All right, it's got a person on a bike, and let's just have them start at rest. And what they're going to do is they're going to accelerate at 1.4 meters per second squared for let's say 7.5 seconds. Okay, so let's just start really simple. So they're starting at rest and they're just going to speed up and go. Okay, so let's see how fast they end up going. Okay, so let's find out how fast they end up actually going. So if for that, what I would want to know is what is my change in v. Now, the basic expression for acceleration, of course, is change in v over change in t. So if I want the change in v, I'll have to just multiply my acceleration and my time. Okay. Now, a lot of people, when they write it like this, it's really common to leave the change in v, and I highly recommend leaving the delta and the change in v in front of the v, not necessarily in t. Most people just write it as a times t, but I highly recommend keeping that delta in the front just so you can distinguish it from other v's. All right, so I have my acceleration, that is 1.4. I have my time, 7.5. So if I map things out, if I got the 1.4 and I'm just going to multiply that by 7.5, I will get 10.5 meters per second. So that was my change in v. Okay, so here he was going 0 meters per second and sped up all the way to 10.5 meters per second. Okay, so not only is that my change in v, that would also be my final v. Okay, now what if we modified this a little bit? What if instead of not starting arrest, so let's get rid of that arrest, maybe he's already going 4 meters per second and then speeds up. So what if he starts at 4 meters per second? Okay, so same question. What's the final v? What is he going to go up to? Same type of thing. Well, this is be a little bit different because now he's starting at 4 meters per second. He's not starting at 0. Now he's starting at 4. But the change in v would still be 10.5. Same acceleration, same time, no problem there. The change in v would still be 10.5. But the final v would not be 10.5 because he's starting at 4. And then it changed by 10.5. So to get the new speed, I would have to add those two together. So the final speed would be the 4 that he started with plus the 10.5, which of course gives you 14.5 meters per second. So he would have sped up and would ended up at 14.5 meters per second. Now here, in the first time we did it, the change in v was 10.5. Same thing here. The change in v is still 10.5. Sometimes the change in v and the final v will be the exact same thing, but only if you're starting at rest. If you're not starting at rest, it's the change in v. It's how much the v changed by. You might have to add. Sometimes you have to subtract. But there's sort of a difference between the two. And sometimes what you'll actually see is you'll often see a little formula called v2 is equal to v1 plus the change in v. Sometimes you'll see that in books and stuff like that. Or you might see it as v2 is equal to v1 plus acceleration times time. You might see that as well. And that's basically what we're doing. Find the change in v, you add it, you subtract it, depending if you're speeding up or slowing down. Okay, all right, so let's try a different question here. Let's get rid of all this and delete that. So let's go with a little tiny, let's go with a spaceship. Okay, so I'm going to draw a little spaceship here. All right, it's a little spaceship. All right. So again, let's just have it at rest, and let's say it speeds up to 120 meters per second, and let's say this took 6.4 seconds to do it. What I want to know is, what is the acceleration? Let's start with that. So what is the acceleration? Well, acceleration is change in v over change in t. So of course the change in v started at rest and it went up to 120. So the change in v would just be the 120. The time is 6.4. So that's pretty straightforward. So I just have to divide the 120 divided by 6.4, and I will get an acceleration of around 18.8 meters per second squared. So there's my acceleration. Okay. Now, what if instead I want to know how far it went? What distance did it travel? So this is similar to the graphing stuff we did. So I want to know how far it went. So distance is dtv. Let's see. Well, the time is 6.4. That's easy. But what about the v? Is the v constant? Well, no, the v is not constant. It's accelerating. So instead of using a constant v, I need to use the average v. Well, let's see. I know it started at 0 and it went up to 120. And the average, of course, is right in the middle. The average v would just be 60. So I'm going to use the average v of 60 meters per second. So I'll do the 6.4 times that by the 60, and it went 384 meters altogether. Okay, so very similar to the graphing type stuff that you guys did. All right, so let's try something very similar. It's a little bit different. Okay, we got a little divider in here, go across. All right, so let's try something else. Okay, so let's draw a little something here. Or some grass or something like that. Okay, let's see if we can draw a little dog or something. Fuzzy tail. Ooh, the kind of big ears for a dog. All right, whatever, something like that. Actually, almost sort of look like a kind of a weird looking dog, but that's okay. All right, we'll give him a little tongue hanging out. There we go. A little tongue hanging out, blah, blah, blah. All right, so you got a little dog. That's a creepy looking dog. Here we got a little dog sitting here. And let's say the dog is, maybe the dog's running along at 7.4 meters per second. And it's going along. And it is going to accelerate. And let's say it slows down to 2.5 meters per second. All right, and the acceleration that it used is going to be, it's a negative acceleration because it's slowing down. So the acceleration, let's say, is negative 1.4 meters per second squared. All right, so first things first, how long did it take for it to accelerate? Okay, so I'm looking for time, so we can do that. So time would be the delta v divided by the acceleration. Okay, so what's my delta v? Well, my dog started at 7.4 and it went down to 2.5. Okay, so obviously it got slower. So if I find the difference between the two, just subtract the two values, the change in v was 4.9. So it dropped by 4.9 meters per second. So the negative doesn't really matter too much for this because, you know, time can't be positive or negative, but it's negative 4.9 was the change in v. My acceleration is negative 1.4. So I'll just divide those two out. The negatives end up canceling out anyway, which makes sense. And it took 3.5 seconds for the dog to slow down. Actually, almost looks like a koala dog, but whatever. So about 3.5 seconds for it to slow down. So let's do the same type thing we did before. How far did it go? So what is the distance? So how far did it go? Okay, so let's do the same type thing we did before. So I want to know the distance. Of course, distance is dtv. It's an average speed because I know there's acceleration. So my time is going to be the 3.5 seconds I just found. I don't have a constant v, so I need the average v. So started at 7.4, 2.5. So I need the value right in between. That's where the average is. So you can just take the 7.4, add the 2.5, just add up the two V's, add them up, divided by 2, and that will give you your average V. And if I do that, it's 4.95. It's actually really close to change in V, but that's purely by coincidence. So that is 4.95 is the average V. So I'll just take that 4.95 and I'll times that by the 3.5 seconds. And my dog went approximately 17.3 meters for the situation. Okay, so there we go. All right. So again, putting VAT and DTV together in one question. So let's try one more question. Okay, so let's draw something like this. Okay, and some wheels. All right, let's just draw person on a scooter. Okay, nice and simple, just a little scooter action going on. And let's say they started at rest. Okay, nice and basic. We're just going to start at rest, and they are going to move forward. And let's say they went, let's go with 6.4 meters in, let's go with 4.8 seconds. And what I want to know is what was their acceleration? Okay, well, acceleration is change in V over change in T. I've got the time, but I don't have the change in V. Okay, I can't find that right away. So let's just look what we've got. So if we look what we've got the 6.4 and we've got the 4.8. We've got distance and we've got time. So with distance and time, I can find V because speed is equal to distance divided by time. I've got distance, I've got time. So if I do that, I've got the 6.4 divided by 4.8. So if I divide 6.4 divided by 4.8, that gives me 1.33 meters per second. Now, which V is this? This isn't my first V, because that's 0, he's at rest. It's also my final V. This is my average, because DTV will always give you constant or average. So we're just going to map out my V's here. We've got, he's starting at 0 meters per second, and he's going at something I don't know. And this is I mean, you've seen me use this graphic, right, as a little line thing. I'm going to use it a lot. I like using my little V line here. I don't know what he goes up to, but I know the average V is 1.33, and that is right in the middle of my V's. So if he started at 0 and he went up to something I don't know, and the average is 1.33, well, let's see, this is plus 1.33. This would also be plus 1.33, or just doubling this, whatever. You can sort of see the final V must have been 2.66 meters per second. So he went from 0 to 2.66, and its average was then 1.33. So that DTV only gives me the average V. So now that I know that, I know we went from 0 to 2.66. The change in V was 2.66 meters per second. Now, the change in V isn't always going to be double the average V. That only happens if one of the V's happens to be equal to 0. But we're just starting out here. So the change in V is 2.66. Now that I have that, I can find my acceleration. The change in V is 2.66. My change in time has not changed. That's still 4.8. So if we divide out the 2.66, we divide that by 4.8, we get an acceleration of about 0.55 meters per second squared.